In this video, we're going to go over a really important concept known as set notation. So what is set notation? So say, for example, I write the following. So I'm going to write x element of z. So let's sort of break down what this means. So here's a variable, and obviously it's x. This e means element of. Element of. And it's not an e, it's sort of like a euro sign, if you will. But it's not an e. Just that's something to remember. It just means element of. So I'm going to put this in quotation marks. And obviously, from our previous understanding, we know that this is the integer set. So if you recall, the integer set is just basically those discrete numbers that are positive, negative, and 0. And that's it. So what this means is that if there's a variable x, it basically is an element of, it only can hold the values that are integers. So if I would write this down as a statement, so x is an element of the integer set. That's what this means, of the integer set. So for example, x can hold the value, say, of 1, of 2, of -5, and lots of values like a -1,000. You can also hold the value of, say, 20 over 2. You might think, well, 20 over 2, that doesn't really look like an integer, but hey, it looks more like a rational number. But as you know, 20 divided by 2 is 10, which also happens to be an integer. So x could take on that value. However, x cannot take on a value. If it belongs to the set of integers, it can't be a rational number. So for example, it can't be half. There's no way it can be half because we've defined x to be an element of an integer set, so which means it can only hold integer values. Let's give sort of another example of this. So if I said x is an element of the natural numbers, then basically all it means is that x can be, say, for example, 1 to 10, a million, right? But x, for example, cannot be -2 because the natural numbers cannot be negative. X can't be 0 because remember, we've defined the natural numbers not to include 0 for our purposes. It can't be, say, pi, or it can't be, say, 2/3 because pi is irrational and 2/3 is a rational number, whereas pi is an irrational number. So that's what that means. Let's do another one. So let's say if I say x is an element of the real number set, so which means x can basically take on any value, pretty much that but it cannot be an imaginary number. So for example, x can equal to half, right? It can equal to an irrational number like pi, another irrational number like e, or even say e over 7, right? So that's still irrational. 2, -3, basically almost any number that you know of, because the real number system comprises of both the rational and irrational set. Now the last one, it's really, really important that you understand this, is if I write this. So x is element of 1, 2, 3, 4, 5. This does not represent a set of natural numbers, because remember, the natural numbers go from 1, 2, 3 all the way till infinity. This is a finite set. It means there's only a set number of numbers. And so what this means, since x is an element of all these numbers, what it means is x can only be any of these numbers, right? And that's it. So x can only be 1, 2, 3, 4, 5. X cannot be, for example, 1.1 or anything like that, or even close. It can only be any of these numbers. All right? So that's basically a small sort of primer on set notation, and it becomes really, really important for everything else in this course. See you in the next video.